Hey everyone, in this video we're going to learn how to solve right triangles. When we're solving right triangles, we're trying to find two different things. First of all, we're trying to find the lengths of all or some of the sides of the triangle. Maybe you need just one side, or maybe you need to find all three. And you need to find the angles. Again, maybe one of them or all three of them. But again, most important that we're doing this only for right triangles. If these are not right triangles, we need more advanced measures to figure it out. But for now, this is only for right triangles. Notice how I draw my right triangles. I've got angle A, angle B, and angle C. But can you notice where do I put the side lengths and how do I call them? Do you notice where A is? Do you notice where side B is and where side C is relative to the angles? Do you notice that they're always opposite of each other from the triangle? So angle A is always across from side A. Angle B is always across from side B. And side C is always across from angle C. So remember that when we label our triangles, we're always going to put the corresponding side opposite of its corresponding angle. All right, but most important, not only these right triangles, but our best friend to help us is good old SOHCAHTOA. Again, sine is opposite over adjacent, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So never forget, that's always going to be there to help us because we're in right triangle land. All right, let's look at an example, friends, and see how we're going to do this. So for here, given this triangle here, here's right triangle ABC. And again, as a little hint to remind you, there's a little box there for angle C, which is your clue that this is a right angle and therefore a right triangle. Well, let's see what we've got here. We do have a side over here. This is side across from angle A, so this would be side A. We don't have side B or side C. We do have angle A, and because he's a right triangle, we also have angle C, but we don't have angle B. Okay, so what's the question asking for? They're saying, can we find here the measures of side B and side C to the nearest tenth? All right, very good. So what we're going to need to do is figure out, first of all, what do we have, what do we need, and therefore what trig is going to help us best. All right, here's some helpful hints for you folks. All right, so for hint number one, we're trying to figure out, first of all, what side are we looking for? And they're asking for side B and C, so why don't we just pick one? How about we pick side B, for example? Okay, we're looking for side B. Now, looking at our triangle, can you figure out what side are we actually given? Which one actually has a legitimate number on it? And that one over here is side A. So we're given side A. Very cool. Okay, well now we're trying to figure, compare it to the angle that they gave us. Not the right angle, but the angle that actually has a number attached to it, meaning angle A. Relative to angle A, what are those two sides here and here that we're either looking for or we've got? Meaning, are these hypotenuse, are these opposites, or are these adjacents? If I look over here, relative to angle A, the side 40 is an opposite. And relative again to angle A, the side I'm looking for, side B, is the adjacent. All right, sounds good. So I've got opposite and I've got adjacent. So based on that, once I'm able to label those with those words, what trig would best be used here to solve? So look what we have. We have opposite and we have adjacent. OA. So going back to up here with SOHCAHTOA, which one has OA on it? And that's your T. That's TOA. Therefore, that's tangent. So on this problem, tangent would be the best trig to use. If by chance you were playing the same rules and you found AH, then you would use cosine. And if you had OH, you'd be using sine. So it really depends on what side you're given, what side you're looking for, and relative to the given angle, what are those guys? Okay, so let's actually use tangent here. And here's how we're going to set up. We're going to set up a little equation over here to solve. Let's say the tangent function of the angle they gave us, and that was A, which was 28. The tangent of 28 degrees is, well, remember, tangent is opposite over adjacent. So again, what was the opposite side of angle A? That would be the 40. And what would be the adjacent side? Would be B. And B is the side that we're looking for. That looks really good, folks, because you notice the only variable that we have there is B. So everything else is a number. Even the tan 28, if I put that in the calculator, that is also a number. But I would hesitate. Don't use the calculator yet, because I'm afraid that I might round a little too early. So let's wait until the absolute last step, and then we'll use calculator. All right. When the variable's on the bottom, probably the best thing to do is think about cross multiplying. So I'm going to rewrite the tan 28 as tan 28 over 1. And then what I can do is I can just really cross multiply like that. So that means that b times the tan of 28 is equal to the other cross, which is 40 times 1, or 40. All right, the b is almost free. What's happening to the b? It's getting multiplied by the tan of 28. Remember, we said that's just a number, so it's being multiplied by a number. Let's divide by that number. All right, if we do it on the left side, we've got to do it on the right side. Therefore, b is equal to 40 divided by the tangent of 28 degrees. All right, now everything's set to go. Why don't we plug that into the calculator and see how we do? Just a little hint, make sure off to the side that you know we should be in degree mode since we're talking about degrees here. All right, in my calculator, I am punching in 40 divided by the tangent of 28. And I get about 75 point, it says the nearest tenth, right? One decimal place. How about 75.2? All right, there you go. And that's how you solve one of the sides. So now that we have that, I can put that back over here. That means b is 75.2. Good. Now, if you want to, we could solve for c by using either trig again, just repeat the same steps, or since we have two sides of a right triangle, we have 1, 2, and we need to find the hypotenuse, we could always use Pythagorean too, but I would say Pythagorean might not be the best here. Only because, remember, in order to find this side over here, we had to round it, right? So that means your final answer over here is also kind of going to be rounded. So maybe it'd be better to use trig, so it'd be a more precise answer. So let's do that. Let's skip the Pythag for now. All right, let's go through our steps again. We were trying to solve for b last time. Why don't we solve for the other one, which is c? So same steps. What side are we looking for? We're looking for side c. Which one are we given of? An actual length. Now, check this out. We are given the 40, we are given side A, but we did solve for side B just now, right? So we actually have A or B. But you know what? For the same reason that I got rid of Pythagorean up here, I'm going to get rid of side B as an option. Why? Because we rounded in order to get that. And again, if I rounded to get that, in order to find side C, I'm going to have to use a rounded answer. So my answer for C might be a little bit too rounded also. Let's use more precise here methods, folks. So why don't we use the side that was given to us, that's golden, and that's A. All right, so going over here now. Now what are those? Compared to the angle A that I started with, what is side C? And side C now, across from the right angle, is the hypotenuse. And how about relative to side A? Side A is the opposite. So this looks like H and O, or in terms of SOHCAHTOA, this would be O and H. So going back up atop to SOHCAHTOA, which one is O and H? There you go. Did you find it? So sine. Sine would be the best function to use here. All right. If you feel like you can try this on your own, can you solve for side C right now using sine? And I'll catch up with you when you're done. All right. Here we go. Let's set this up. How about the sine of that angle that we were given was 28 degrees. Equals opposite over hypotenuse, that is the 40 divided by the hypotenuse, which is c. Okay, let's do the same thing. We're going to cross multiply because the variable is in the denominator. So we'll cross and we'll get c times sine 28 equals 40 times 1. Let's divide by the sine of 28 since it's just a number. Make a little bit of space here for us, folks. And let's see what we got. Therefore, c is equal to 40 divided by the sine of 28. All right. Thank goodness we didn't use the calculator yet. We didn't round too early, so we saved it for our last step. Here we go. In my calculator, I'm punching in 40 divided by the sine of 28. And I get that it's about, to the nearest tenth, 85.2. All right. Now, we should just double check and use a little bit of common sense. Okay, let's erase everything over here in our triangle. Let's put the final answers and see if it makes sense. Ready? You found that side B was 75.2. Awesome. You found that side C, the hypotenuse, was 85.2. Now, look and see. Use a little bit of common sense. Do you remember, in a triangle, which side is always the longest, especially in a right triangle? It is the hypotenuse. So check and see. When you do these solving right triangles, use a little bit of common sense at the end. And check and see, is your hypotenuse the longest side? And here it is. Good job. That means you probably did it right. Now, could you check? Sure, you could do a squared plus b squared equals c squared and check that too. Either way is fine. So that's how we solve right triangles, using the given information and what you're trying to solve for to pick a good trig function to make an equation out of. All right, you want to try one on your own? How about right down here? Here's a new triangle, ABCD. And how about you solve for all the sides? And as a bonus, let's see what you remember. Can you also solve for angle A? Let's see if you remember how to do that. Okay, I'm going to pause the video. Go ahead and try it on your own. You can come and check back when you're all done, folks. Good luck. All right, I am back. Now, I'm going to actually solve for that angle A right now, just because that's a pretty quick step if you remember. You remember in a triangle, all the angles have to add up to 180 degrees when you add them all up. So basically that would be angle B plus angle C plus angle A should all add up to make 180. So you could do that, or if you also remember in a right triangle, the angles that are not the right angle should be complementary. They should add up to 90. So the 56 from B plus whatever angle A is should also add up to 90. Either way is fine. You can add up all the angles to 180 and solve, or you can just add the two non-right angles and make them equal to 90. But either way, when you solve, you get that A is equal to 34 degrees. Great. Now, when you solve for the leftover sides, can you use A equals 34 as your angle instead of like the angle 56? Sure. Absolutely, you can use either this angle or that angle. Just be careful which sides you're doing reference to which angle, because it makes a difference with the SOHCAHTOA. All right, so let me write that in. Angle A is 34 degrees. All right. So let's pick. We got side A and side B. I think I'm just going to use side A. I'll go in order. Let's solve for side A. Looks like we're given side 15 over here, which is your hypotenuse. So I'm looking for A, and I was given C. Let's see, those are, okay, well, I should probably pick a good angle. How about we pick B to challenge myself? Relative to angle B, A is the adjacent, and C is the hypotenuse. Okay, so we've got AH. Which one is AH with SOHCAHTOA? That would be cosine. All right, so I'm going to use cosine to solve for side A. If by chance you use the 34-degree angle over here instead as your reference, that means to solve for A, you probably should be using the sine, just to check and see. All right, here we go. Let's take the cosine of the angle 56 that I chose equals adjacent, which is side A, over the hypotenuse, which is 15. All right, that looks pretty good. SOHCAHTOA. Now, do you notice that the variable is actually in the numerator? He's on top. So cross multiplying is fine. You can do that if you like. Or do you notice that the only thing that's happening to the variable is he's just being divided by 15? So why don't I just undo that by multiplying both sides by 15? Okay, cool. So I get A equals 15 times the cosine of 56. Awesome. How about I just put that in the calculator right now? Again, saving the calculator for the last step. All right, I'm going to do the cosine of 56 first, multiply by 15. And I get that side A is about 8.4 for using nearest tenth again. Very good. So that's side A, 8.4. All right, shall we repeat and do side B? I'll use side B, and I'll use side C again. Relative to the angle B, this is opposite. And again, hypotenuse. Which one would be opposite of hypotenuse? OH, SOHCAHTOA, would be sine. Let's pick sine for this one. All right, I'll do this over here. How about the sine of 56 degrees is opposite, which is side B, over hypotenuse, which is the 15. And we can solve this the same way we did before by just multiplying by both sides by 15. Okay, kills that, and I get b equals 15 times the sine of 56 degrees. Here comes the calculator. I'll do the sine of 56 and multiply by 15. I get about 12.4. Did you get the same thing? If you did, congratulations, good job. Now, we should do that little double check, right? Just to make sure everything looks okay. I've got a side of 8.4. I've got a side of 12.4. And my hypotenuse is definitely longer than that. That's great. Not only that, a little bit of a bonus way to check. Do you remember in geometry, the longest side is always across from the largest angle. So the largest angle here, of course, is the 90. So the 15 is across in there. Good. What's the smallest side? Okay, found it. It's over here. Is he across from the smallest angle? Yes, he is. That's great too. Another great way to check just using basic geometry. Longest side across from largest angle. Smallest side is across from the smaller angle. And there you go. Now, it's great that we're able to find the angles really easily because we were given one of them. But what if we weren't given either of them? Ooh, then we're kind of trapped, right? What if I want to find any of these angles here? I know that he's a right triangle, ABC, but I don't know him and I don't know her. So how can I find those? I'm given some sides. Do you remember from your geometry days, we have to use what's called the inverse of an angle. The angle inverse, like the sine inverse or the tan inverse, to try to find the angles. We always use inverses to find angles. We use the regular trig on this last page to find the sides. Regular trig to find sides, inverse trig to find angles. Ready? Let's pick an angle and see if we can solve for it. All right, well, I'll just start with angle A. Can we solve for angle A? Now, it's sort of the same steps. Let's see what we're given and what trig would be best. Now, look and see how we're given this side here and this side here. Relative to angle A that I'm looking for, what are those two sides? Well, the 5 is the adjacent, and the 13 is the hypotenuse. So what trig function uses adjacent and hypotenuse? AH would be a cosine. So I'll use the cosine function to solve for angle A. But watch, I don't know what angle A is, so here's how I'm going to write it. I'm going to say cosine of angle A, which I don't know, so I'll just leave it as angle A, equals, ready? How about SOHCAHTOA? Adjacent over hypotenuse. So the only variable that you're solving here, folks, is the angle A. Great. Now, the only way to get that A by itself is to somehow get rid of the cos. Unfortunately, we can't just divide by a cosine. It just doesn't make sense because the cosine and the A are sort of a package deal. Like, you can't just like rip it away. It doesn't make sense. So we have to find another way of undoing the cosine. And the way to do that is by using, yep, you guessed it, the inverse. Watch what I'm going to do. I'm going to undo the cosine by taking the cosine inverse of the left side. Now, if I'm going to do that to one side, I got to do it to the other side, right, to balance it out. So I'm going to do the cosine inverse of the right side too. So this really looks like this, folks. The cosine inverse of the cosine of A. On the right side, the cosine inverse of 5 over 13. Awesome. The reason why I do that, look what happens to the cos inverse and the cos. They're like opposites, right? So, bye, and you're left with A. Hey, that's what you're looking for, right? Awesome. So angle A is equal to the cosine inverse of 5 over 13. All right, now we just got to put that in the calculator. Do you remember how to do that using the cosine inverse? The trig inverses are usually on the calculator, but they're above. They're above the regular functions. So I'm going to do, first of all, how about cosine inverse? So do second cosine, and I'll do 5 over 13. And then hit enter, and we'll see what we get. And when you do it, you know you did it right because I got a big number that sounds like an angle. I got about 67.4 degrees. That sounds about right. Yep, I just double checked it again. I got 67.4. So that's how much angle A is. Angle A is 67.4 degrees. So we use inverses to find the angles if we need to. Pick the sides that are best, and the ones that are best are 5 and 13. Why? Because they're both numbers, and they're both given to us. If we use the A, then we'd have too many variables up here. We're trying to solve for too many things. Make it simpler on yourself. All right, we had to solve for A. Can we solve for b? Ready? Should we use trig again? No, we don't have to. Why not? Well, because you already found 67.4. You know this guy is 90, so you can set them all equal to 180 and solve. Or, again, like we talked about before, we can just take these two friends that are complementary and set them equal to 90 and solve. So if we do that, 67.4 plus angle B is equal to 90. Therefore, angle B is equal to, how about 22.6 degrees? So if you want to use inverses, great. You didn't have to because you had all the other angles in that triangle. But we're not done because it does say solve, so it means you have to find all the sides or angles. We found the angles. We've got most of the sides, but we're missing this friend. How can we do it? Pythagorean would be absolutely fine. Or trig would work too. All right, well, we can practice trig, but just for the fun of it, why don't we end with some Pythagorean? How about a squared plus b squared? Well, you know what? If I'm going to say a squared, I should use a squared, Mr. Brown. How about a squared plus, let's let the 5 be the b squared, equals c squared. A squared plus b squared equals the hypotenuse squared. So a squared plus 5 squared is 25 in my book. 13 squared, whew, how about 169? That means a squared is equal to 144 when you subtract 25 on both sides. Ooh, square root, that's a really pretty one. You get 12. And this is actually a famous Pythagorean triple, what's called the 5, 12, 13. All right, let's double check. Did we get all our sides? Yep, yep, and yep. Did we get all our angles? Yep, yep, yep. Can we use a little bit of geometry and just double check? The smallest angle is B. The smallest side is side B. That's great. The largest is 13. The largest is the 90. So using a little bit of geometry, we are good to go. And we are trig pros. Great job, folks. So now you know how to solve a triangle, either solving for the sides using regular trig, SOHCAHTOA, which is always our friend, or using the inverse trig to try to find the angles. Great job today. We'll see you next time.